Okay, decide whether it's linear, absolute, or exponential, or other. Oh, or exponential. Okay, how do you rule out linear? How do you rule out linear? See if the change in y over x is the same. If you have, the positive and negative version of the same number, that's absolute value. Alright, so let's see. Plus 4 over plus 1. Up 4, up 1. Changing y over x. Those are equal. Went up 4, up 1. Up 4, up 1. Okay, that would make this linear. A rock is constantly 4. No common ratio. Change in y over x stayed consistent throughout the interval. And we already know that's we know that's m. Let me try to fix the little blurry. Alright. Okay, it says write a so we know m is 4. Y-intercept, where x is 0. Anytime I can get it in slope-intercept, I do. So here's b. Put it together. I'm going to pause it while I highlight. Okay. Changing y over changing x. Up 2, up 3. Slope is 2/3. Okay, 2/3. Two-thirds. Okay, now we're cooking with grease. Because now we're going down to, so this makes this the vertex. It's the point that changes directions. See, it's negative 2/3 here. Down 2, up 3. Okay, this is absolute value. How do you know? So A rock, how do I know it's absolute value? 2/3, it's the positive and negative version. And you can write, I think in like Math Excel, you could put plus minus 2/3. There's no common ratio. Change in y over x is 2/3 or, okay, which way does it open? Okay, so A is found between vertex and first point to the right. Okay, so this question is, okay, the slope's 2/3, 2/3, 2/3, so it's going up. It hits the vertex and then it starts going down 2, right 3. So this one would open down. So A is this one. Okay, what do we need for the equation? We need the vertex. We need the change in y. We need A. A is always the first point to the right. So y equals A x minus 3 for the vertex plus 2. This is where we did that bullet yesterday. Okay, I'm going to pause it while I highlight my answers. I copied that one badly. Oh, that one's easy. Okay, so there's many ways I could show you how to do this. I'm always going to err on the side of... Okay, I'm going to always err on the side of... Alright, so... Maybe I need to think the space. Yeah, okay, that'll have to be it. Okay, so I'm going to give you the easy way, and I'm going to show you a different way. The easy way is simple, is me, I take it one step at a time. So I got 4z to the negative 1. So I got 4z to the negative 1, and down here I'm going to do negative 3z to the 5 times 3. And like I said, I'm going to show you what I think is the easiest way, and then I'll show you the I really get this way. Okay, for me, I do this. Okay, I play, let's do one more step, and I'll play a game called Stay or Go. That's 4 to the first, z to the negative 1 over negative 3 to the first. And now I got z to the 15th. Okay, if you have, so I'm going to make a fraction bar. And if it's a positive exponent, it stays in the numerator, it stays where it is. So 4 is going to stay up top. Z is going to move to the bottom, but I'll move it here in a second. Down here we still got that negative 3. Okay, z to the 15th on the bottom. I go ahead and I'm going to transfer z to the negative 1. If I want to make it to a positive power, I take it down into the numerator. Okay, and your final answer would be, I just bring that negative in front of everything because that's the way it is on the state test. We're going to go negative 4, 3, z to the 16th. Okay, if you like that way, do it. I want to show you a different way. Let's say you really get these laws and you do this step. Okay, let's say you're really good at them and you understand multiplication. So you could do negative 4/3. This is OR. And then you could do times z to the negative 1 minus 15. And like I said, if you're good at integer rules, okay, we get negative 4/3. Okay, z to the that's going to be z to the negative 16. So that's going to move to the bottom. So, but me personally, I think the top way I did it is actually easier. That's the way I think is easier. Okay, I think I got enough space to work them each the easy way. Okay, so this one, I don't think I have enough space to the right to write my next step, so I'm just going to bring it down. Okay, we got 2 to the first to the second, and then we have m to the fourth to the second, and then x to the fifth times 2. Power to the power, you multiply, so now I got 6x squared over 2 squared, m to the 8th, x to the 10th. And again, I'm showing you the easy way. Okay, 2 squared, hey, that's 4. Two squared is 4. Okay, 2 goes into 6 3 times. 2 goes into 4 twice. Okay, I call this the factor it out way. I can factor 2 x's from the top, and that gives me x to the 0, which is 1. And I'll take 2 x's from there. Okay, now I have 3 over 2 m to the 8 x to the 8. Okay, there's a variation there that you could do. Or you could do 6/4 times 1 over m to the 8. And then you could do x to the 2 minus 10. Okay, hey, that's negative 8. So if you're really good at this, you get 3 over 2. M to the 8 stays here. 2 minus 10 is negative 8. So if you're really good at integer rules, wait, that makes it positive. Okay, we get the same answer. But to me, I think the top way I went over it is best. That's the easiest way. Now, could you do the blue way? Yeah. Okay, so I'm going to move this one over here. It didn't copy right. I'll just rewrite it over there. This one's a cakewalk. Let's go ahead and do it. Alright, this means p times 6 more p's. So that one's easy. We're multiplying p by itself 8 times. That one was a joke. Okay, this one, ooh man, this one's a tough one. Okay. So this is going to be difficult, okay? This is the toughest one I've seen on all the classworks. That's 4 to the first. Okay, so let me work on it's blurry. That got worse. Pause it. I showed too many steps. We got to do 4 to the first times negative 3. Then we got to do x to the negative 2 times negative 3. Then we got to do j to the 3 times negative 3. And there's nothing really we can do down on the bottom. Okay, anything divided by itself is 1. So x to the 6 divided by x to the 6, you get 1 there. Okay, now I play a game called Stay or Go. Okay, I'm going to write a big fraction bar. Okay, if it's got a negative exponent on it, we move it from the numerator down to the denominator. So 4 to the third would move down here. J to the ninth from the top, it'd move down. Okay, what's already down there? Well, we got times 3. Okay, 3 to the first. Okay, now j to the negative 4 is in the denominator. To make it positive, I move it up. So I got 1 times j to the 4th over that. Okay, now 4 to the 3rd is 64. Okay, I could factor out all 4 j's from the top. That gives me 1 times 1. So on top we got 1 over, okay, we got 4 times 4 times 4 times 3. Sixteen times 4, 64. 64 times 3, 12, carry the 1, 192. And you still got 5 j's down there. I don't want this video taking 30 minutes, so that's a tough one. Okay, last one. Power to a power, easy peasy. Means 3 to the 1 times 3. I use parentheses for multiplication, because you see there's a parentheses, a big one there. That's how I remember. Okay, we got 3 to the 3rd. X to the 6th, y to the 6th. We got to find out what the coefficient of x to the 6th, y to the 6th would be. 3 times 3 is 9, 9 times 3, 27. Okay, that one was easy. Okay, this is, let me zoom. Okay, I think ahoy. Okay, and this is dash above. So dash above is greater than. Okay, it's a horizontal line that crosses the y-axis. So we do y. Okay, we have to do greater than -4. Okay, changing y over changing x, that's 0. It's 0. A lot of people miss that on quizzes. It's got a y-intercept. Okay, I want you to think of bucks here. It hits the x-axis at 2. So this is y equals. Okay, so this is an x equal equation. And less than is dash, shade left. So it's less than. So x is less than 2. Okay, people miss this on a quiz all the time. The change in y over change in x is undefined. See, undefined slope. Vertical line. x equal equation. Okay, this is absolute value. Okay, here's the vertex. Notice it's going by 2's in all directions. I didn't notice this till just now. Okay, this might really annoy you. Okay, so the vertex is 0, 2. A, okay, this opens down. So A is less than 0. Okay, so to find A, you go down 1, right 1. Okay, now you put it in vertex form. Y equals, that's HK. Negative goes in front of the absolute value. You don't put x minus 0, you just leave it like that. And then K is the same. Okay, I want you to think of Hoy again. This hits the y-axis at 4. And the change in y over change in x, again, is 0. M was undefined. M here is 0. Okay, this is something from, let me pause it and highlight. Okay, I wanted to go over this in class, so I added this. It says domain. Domain is all the x values. Okay, there's 2 ways we could write this domain. This is x is greater than or equal to negative 7. And this one is x is less than 3. Okay, so if they meet in the middle, you could say x is greater than negative 7 and x is less than 3. Or you can write it as an interval, which is the way I write it. It's like we need the x's to be bigger than negative 7 but less than 3. Equation M I made this one myself. No, that's not one. Okay, I went up 1, right 2, y-intercept 0, 4. Wait, no, not 1/3. 2/3. I'll mess all that up. Yeah, that's it. I went up 2, right 3. So it's y equals 2/3 x plus 4. Okay, the range. Y is greater than or equal to 0. Y, is less than 6. So the range goes from, it can be 0, and then it can't be 6. H of negative 3, whoopsie. 2.5. Accidentally wadded it out. This is a bad graph. What was I trying to do? What? Oh. think I'll just throw that question out. H of 3 does not exist. So I messed that one up a little bit on, I really messed that one up. But to me, that's what think I had in my head. D&E stands for does not exist. Okay, here's another domain and range. Goes from -3 to 1. Okay, so you can go from -3. It can't actually be -3. Okay, but X can actually be 1 because of that closed circle. Okay, what's the equation? Again, I made this one myself, and it works. This one actually works well. -2 over 1. The y-intercept is -3. Okay, range. Again, I just draw arrows over to the y. Y is greater than or equal to -5. The highest y is 3, and it can't actually be 3. So it's somewhere between -5 and 3. Okay, h of 0, that's the y-intercept. So what's y when x is 0? -3. Okay, h of -3. Y, it does not exist.